Hello and welcome to this session. Today, we will learn to connect 8 LEDs to the port of microcontroller and blink it with a switch. Microcontroller is a component which can be considered as a small computer enclosed with a processor with memories both RAM and ROM.
Objectives. At the end of this session, you will be able to enter the program to blink 8 LEDs using a switch and run it on the microcontroller trainer kit, and check the result through port 2 and record the observation. Next, we will look at the tools and equipment needed to connect 8 LEDs to the port and blink the LED with a switch using 805 and microcontrollers. For this, you will need the following tools and equipment: PC or laptop 1 number, microcontroller kit 1 number, USB cable 1 number, FRC cable 2 numbers, FlashMagic software, and Keel Microvision software. Let's now see the procedure to connect 8 LEDs to the port and blink the LED with a switch using the 805 and microcontroller. It involves 3 steps. Step 1. Write the program for 805 and microcontroller using Keel software. Step 2. Burn the converted file using FlashMagic software to the microcontroller IC. Step 3. Assemble the circuit by connecting the hardware parts and execute the output. Now, we will run the program using the software called Keel Microvision software. Switch on the computer and open the Keel Microvision software. Once you have opened the software, click on Project and select New Microvision project. Save the program in the folder named as 805 in microcontroller where we write our program. Create file name as per the project. Here, it is named as 8 LED blinking using one switch. Click Save to proceed. A tab pop-up appears to select the microcontroller. Here, we are using 805 in microcontroller. Select AT89C51 from the database and click OK. Click No for the start file. On the left side of the screen, a tab called Project appears. Click on the plus beside the target one. Now Source Group opens. Right-click on the Source Group 1 and select Add New Item to Group Source Group 1. Select the .asm file since we are writing the program in assembly language. Name the file here. It is named as 8 LED blinking using one switch. Click on the Add to add it on the Source Group 1. Now start entering the program in the .asm file created. org00h. This means setting the origin of the code to address 00h. L1 : move A, P1. Here, L1 is the loop for performing the action. Now we are moving the value of port 1 to the accumulator register A. This acts as an input port. ANL A, /01H. ANL means bitwise AND operation with 01H, 0000, 0001 and accumulator A. JZL1. JZ means jump to label L1 if accumulator A is 0. Move A, #0FFH semicolon. Now move the hexadecimal value FF to the accumulator register A. According to the hexadecimal value, the LEDs will be blinking. Move P2, A. This defines moving the value of accumulator A to port 2. This port acts as an output port. A call delay. This means calling the subroutine delay. Move A, /00H. Move the hexadecimal value 00H to the accumulator register A. Move P2, A. We are moving the accumulator A value to port 2. This will display the output according to the hexadecimal value given. A call delay. This means calling the subroutine delay before the next action. SJMP L1. Now, SJMP means short jump for indefinite loop jump to the loop created L1. Delay colon move R0, comma slash 0FFH. In the previous lines, we have called delay. Start writing the delay program. Move the hexadecimal value 0FFH to register R0. L2 colon move R1, comma slash 0FFH. Move the hexadecimal value 0FFH to register R1. L3 colon DJNZ R1, L3. Creating a loop for decrement R1 and jump to L3 if it's not 0. DJNZ R0, L2. Decrement R0 and jump to L2 if it is not 0. RET. Return from subroutine. End. End of the program. Now navigate to the target and right-click and select Options for Target 1. Change frequency to 11.052 MHz. Select the box of the use on chip ROM. Now go to Menu and select the output. Enter the hex file name in the name of executable. Here, it is 8 LED blinking 1 switch. Select the box of Create Hex File and click OK to continue. Navigate to Menu and select Translate and check whether there are any errors or warnings. In the build output, it will show the number of errors and warnings. Now next to the translate, there is an icon named and click on the build target. In the build output, it will be displayed as creating hex file from 8 LED blinking 1 switch. 8 LED blinking 1 switch. 0 errors, 0 warnings. Turn on the microcontroller kit after entering the program in the software. Now connect the laptop to the microcontroller kit using the USB cable. Connect one end of the cable to the laptop and other end to the microcontroller kit. Now click Windows on the keyboard and type FlashMagic to burn the code. Now in step 1, select the microcontroller. The microcontroller specification will vary from kit to kit. Here, we are using 89V51RD2. Now for selecting the COM port, click on Windows and type Device Manager. Navigate to ports COM and LPT and check the port number. Here it is COM20. Now open FlashMagic. Select the COM port as COM20. It varies from kit to kit. Select the baud rate as 9600 and interface as None, ISP. Click on the box of Erase All Flash to erase all the programs previously done in the kit. Now go to Step 3, Firmware, and browse the hex file created and select the hex file. Navigate to Step 5 and click on Start. Now click on the Reset button in the microcontroller kit to dump the program into the kit. Connect the ports according to the program. Locate the ports, switch, and LED in the kit. Use FRC cables female to female for connecting the ports. Here, port 1 is connected to switch and port 2 is connected to the LED. Now click on the Reset button again to burn the program. According to the program, we have given 000000101H. This means only the bit 0 switch will control the LEDs and other switches will not be controlling the LEDs. If we set the bit 0 switch to high, LED will be blinking according to the program. In the program, we have defined when the switch is high. LEDs will be in FF and 00 with a delay. If we toggle the bit 0 switch to low, we can see there is a change in the output LED. All the LEDs are off according to the program. Now let us try to change the controlling switch for blinking LEDs. Give hex decimal value as 10H in the ANL operation and blinking of LED as 0FFH and 00H in the Keel software. Build the target. Open the FlashMagic and browse the updated hex file and start executing the program. Click Reset to dump the program. Again, click Reset to burn the program. Now toggle the bit 4 switch to high. See the LED. It will be blinking in the FF and patterns. Now toggle the bit 4 to low and observe the LED. It will be in off state. Now toggle the other switches. There will be no change in the output LED's state. Now let us try to change the controlling switch for blinking LEDs. Give hex decimal value as 02H in the ANL operation and change the blinking of LED as 0AAH and 055H in the Keel software. Build the target. Open FlashMagic and browse the updated hex file and start executing the program. Click Reset to dump the program. Again, click Reset to burn the program. Now toggle the bit 1 switch to low and high and see the LED. It will be blinking in the AA and 55 patterns. Now toggle the other switches. There will be no change in the output LED's state.
This brings us to the end of this session. In this session, we have learned to program the LED to blink with the switch and design the LED with the switch using 8051 microcontroller. Thank you for watching. We will see you in the next session.